Hello everyone, this is the first question, practice question in arithmetic progression. It's a lovely question. It helps us get clarity on 2 points. The first point is, do we have a good understanding about the definition of an arithmetic progression? What kind of a sequence of numbers will be called as numbers in an arithmetic progression? That is what is tested in this question. The second part is, if we know it is in an arithmetic progression, how does one compute the nth term of an arithmetic progression, right? Second part is more or less applying the formula with a small twist to it. But the first part is where I want us to have a good clarity on what kind of a sequence is said to be a sequence in arithmetic progression. Let's start with the question. There are two parts to it. Do the terms 13, 6, minus 1 form an arithmetic progression, right? So we need to know what is an arithmetic progression to be able to say whether this forms a part of an is it in an arithmetic progression. The second part of the question is, if the answer is yes, if 13, 6, minus 1 is in an arithmetic progression, check whether minus 162 is a term of this arithmetic progression. This is where we will be applying the nth term formula. How do you compute the nth term of an arithmetic progression? Let's start with the first part. Terms given to us are 13, 6 and minus 1. We are going to check whether these terms are in an arithmetic progression. How does one define an arithmetic progression? An arithmetic progression is a sequence of numbers in which the difference between any two consecutive terms is the same, and that difference is called the common difference. So, the difference between the second and the first term, if it is the same as the difference between the third and the second term, is the same as the difference between the 10th and the 9th term, right? The difference between any two consecutive terms is the same, then that progression, that sequence is said to be in an arithmetic progression, right? So, quickly write that down here. If the terms are in an arithmetic progression, difference between any two consecutive terms will be the same. How many terms do we have? We have 3 terms. The first term, we'll call it A1 is equal to 13. The second term, A2 is equal to 6. The third term, A3 is equal to minus 1. It is actually decreasing, it's not increasing. It can very well decrease, right? Let's find out the difference between the second and the first term, which is A2 minus A1, which is 6 minus 13, which is equal to a negative 7. Don't worry, because it's a minus 7, it need not always be a positive number, it need not be a positive integer, it can be a 2.3, it can be a minus 0.5, all of those are perfectly valid differences between two consecutive terms. We found out the difference between the second and the first, that turned out to be a minus 7. Let's find out the difference between the third and the second and see what answer we get. A3 minus an A2 is minus 1 minus 6, that is also equal to minus 7. So, difference between the second and the first term is a minus 7. The difference between third and the second term is also a minus 7, which means the difference between any two consecutive terms is the same, and that is called the common difference. So, common difference is denoted by D, that is equal to minus 7. That essentially means that the given sequence of numbers, which is 13, 6, minus 1 is in an AP. The answer is yes. So, part 1, it's an yes. How did we prove it? We proved it by the fact that a common difference exists. Let's move to the second component. Let us check whether minus 162 is a term of this arithmetic progression 13, 6, minus 1. We know that is in an arithmetic progression. That's part 1, done and dusted. Now, all that we need to check out is whether minus 162 is a part of this arithmetic progression. Let us for a moment assume that minus 162 is a term of this arithmetic progression. So, we will call it the nth term. So, an is equal to minus 162. How do you compute the nth term of an AP? The formula for that is A1 plus n minus 1 times the common difference. Before I venture into explaining how we are going to determine that, let me just plug in whatever data I have in this particular equation. An is minus 162, that's where we started. The first term A1 is a 13 plus n minus 1 times the common difference, which is a negative 7. Now, look at this equation. There is only one unknown, one variable, which is n. So, if I solve this equation, I am going to get the value of n. Now, what is the question? The question is not what is n, the question is minus 162 a term of this AP? Having got a value for n, how does one determine? Let's just explain that right now before we find the value of n, right? If minus 162 is a term of this progression, then what will you say? It could be the 28th term, it could be the 19th term, it could be the 5th term, it could be the 100th term, right? So, the value of n, if it is a term of the sequence, will be a positive integer, because otherwise it cannot be a term of this sequence. Conversely, if we solve this equation and we get for a moment, say that n is equal to 11.3. Look at it, 13 is the first term, 6 is the second term, and minus 1 is the third term. Do we have a 2.1th term? Do we have a 3.9th term? You don't have such terms. You have first term, second term, third term, fourth term. That's what you have in an AP. So, if n is a positive integer, then 162 is that nth term. It could be the 29th term, it could be the 43rd term. But if n ends up being something like 11.3, then it essentially points to the fact that 162 is 11.3rd term, but there can never be 11.3rd term, which means minus 162 is not a term of the sequence. So how do we determine? We'll compute the value of n and check whether n is a positive integer. If it's a positive integer, then minus 162 is a term of the sequence. If it is not a positive integer, if it contains a decimal, or if it ends up being a negative number, you won't say it's a minus 4th term, right? So you can only have the 3rd term, 5th term, 7th term. So if it is either a non-integer, or if it's a negative number, or it's a non-positive integer, then we'll say minus 162 is not a term of the sequence. Quickly run through it. Take this minus 7 times n minus 1, we'll take it to the left hand side. That will become 7 times n minus 1. This is equal to 13 plus 162. So 7 times n minus 1 is equal to 175. Let's divide both sides of this equation by a 7. We'll do it in the next slide. So that will leave us with n minus 1 to be equal to 175 by 7, which is equal to 25, or n is equal to 26. N is a positive integer, so minus 162 is a 26th term of the sequence, so it's a part of the sequence, definitely yes. Because n is a positive integer, we can answer the second question also as an S, right? Quick recap, we understood two concepts here. The first one, how do we define a sequence to be in an AP? It's in an AP if the difference between any two consecutive terms is the same. Second one, how do you determine whether a term is a part of the arithmetic progression? Substitute all values, compute the value of n. If n is a positive integer, that particular term is a part of the sequence. If n is a non-integer, or if n is negative, or if n is 0, then it's not a part of that sequence, right? Best wishes, guys.
Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.